What you're looking at on your screen right now is actually an XY chart. We are going to use this XY chart to graph the function y equals sine of x. So this is the parent function for sine. We are going to use the unit circle to fill in this XY chart. So if you're unfamiliar with the unit circle, I would encourage you to figure out what I'm talking about before you watch this video. I've included a video in the description with how to find ordered pairs on the unit circle. It includes this circle that I have on the screen right now. It is where all of those blue ordered pairs came from. The unit circle is extremely important when you're trying to graph your sine and cosine functions. So in this video, I'm going to demonstrate how to graph the sine function. So just like any other XY chart, I've got x values. I'm going to plug those in to find y values. My x values are either measured in degrees or radians. It's really up to you whether you prefer degrees or radians. You're going to plug those into the function. You're going to plug those in for x, and you're going to find sine of that angle, and that's what we're filling into the chart. So we're going to create ordered pairs that we're going to put on a graph. Now the first x value I have is 0 degrees or 0 radians, whichever you prefer. Looking at the unit circle, 0 degrees is over here on the right. Sine of 0 degrees is just the y value of that coordinate at 0 degrees. So sine of 0 is just equal to 0. Moving counterclockwise, the next angle would be 30 degrees. Same thing here. Sine of 30 degrees is just the y value of that coordinate. In this case, that's 1/2. Moving on to 45 degrees, you're always going to have square root of 2 over 2 involved when you have an angle ending in 5 on the unit circle. In this case, since we're in quadrant 1, sine is going to be positive. Next angle would be 60 degrees. Sine of 60 degrees would be square root of 3 over 2. Up at the top would be 90 degrees. Sine of 90 degrees is 1. That's the y value of the coordinate. And then you just work your way around the circle. You're going to see the same numbers over and over again. They may be positive, they may be negative, but these numbers that I have listed are the only ones that you're going to see for the rest of the chart. So if you move on to 120 degrees, that's in quadrant 2. Sine of 120 would still be positive because we moved up to get to 120. That would be square root of 3 over 2. And now I encourage you to finish the chart on your own, either with a unit circle in front of you or try it from memory, because you do need to have the unit circle memorized eventually. So go ahead and pause the video if you want to do that. This is what the chart should look like when you're done. So if you tried it on your own, go ahead and pause to look at the numbers again. Make sure you got them all right. Now that the entire chart is filled in, I'm going to graph the sine function. So to save some time, I have a really beautiful drawing of almost all of those points. Okay, remember, sine at 0 degrees was 0, 0. So that's where this point came from. Sine at pi over 6 is 1/2. So that's where this point came from, and so on. So in this case, the x-axis is measured in radians. If you're more comfortable with degrees, you could have done it that way. The y-axis was our output. Those were the values that we filled in red in that chart. Now remember, periodic functions go on forever, so please remember that it does not just exist between 0 and 2 pi. So here's a wider shot of your sine function. I've labeled some of those key points, like 0, 0. Now, a couple features of periodic functions really quick. If I start here at 0, 0, and I trace the graph until 2 pi, you'll notice that that is one cycle of the sine function. Once you get past 2 pi, the cycle starts again. Same with the left of 0. It's the same pattern over and over again. That's why these are periodic functions. So if you look between 0 and 2 pi, that's one cycle of the graph, which is one period. So with the sine function, your period is equal to 2 pi. So it takes a length of 2 pi to get through an entire cycle of the sine graph. Another feature of periodic functions is the amplitude. Remember, that's the height, but you're not going from the very bottom to the very top. You're starting at the middle and then either measuring to the top or to the bottom. So in this case, if I start from 0 and I go to the very top, I can't go past 1. If I start in the middle and I go to the bottom, I can't go past -1. So the periodic function will never go above 1 or below -1 in this case. So the amplitude for the sine graph is just 1.